Hello everyone, welcome back to my channel. In previous video, we were discussed about a serverless microservice architecture with AWS Lambda. So now, as I said, a continuation topic to it. So I'm going to cover that AWS Lambda with Node.js microservice, how that flow is going to be worked out. We're going to discuss those details in this video. Thanks and welcome back to my channel. So today we are going to discuss about this AWS Lambda with Node.js microservice flow. So first here the client will send the request, HTTP request to AWS API gateway. It's another Amazon web service. So API gateway, which is acts as a kind of gateway which accepts your request and have the responsibility to send back your response. Okay, so once the request come from a client application to Amazon API gateway, so it triggers a Lambda function. As today, I mean in previous video we were discussed there is a Lambda function which is going to be work without any server. So the cloud native application, it's going to provide a feasibility to us to execute any piece of functional logic without rely on a server. So now Express or else Node.js, whatever we are discussing, Express is a kind of server which is going to expose your controller endpoints as a service. So now it require a server, right? Generally, Express itself is a server. Then how you going to run a Node.js microservice application with Lambda? That is what we are going to discuss deep dive in this video. So now the serverless function AWS side, we have AWS Lambda. Similarly for GCP and then Azure, you'll have a similar serverless function capability related cloud service. You have to use that. So in this series we have been covering with AWS. That's where I was taking the consideration of example with AWS Lambda. So now the API gateway, once it receives the request, it triggers a Lambda function, and Lambda have actually its own functionality to set up which runtime environment that you require. So in this series, in this example, we are covering with Node.js, right? So Node.js is a kind of JavaScript runtime environment. So it's a kind of one JRE, JavaScript runtime environment. Similarly, you want to run Java, that is also been possible. So for that, you have to choose a JRE, Java runtime environment. Similarly, you can also, in case of this AWS Lambda, you want to execute a runtime environment for Python, you can use that Python related runtime environment. So here we are covering with Node.js. That's where I was going with choosing a right Node.js runtime environment to execute my JavaScript runtime, JavaScript code in the runtime. So Lambda will take care of its creation and then exposing that information and then managing of that entire service. I mean, as we discussed, right, auto scaling, when it is an auto scaling or else CPU usage and then the instance is increasing and decreasing, everything will be taken care by Lambda based on the hits that we are receiving from API gateway to here. It is going to take care of that control completely. So now once the request receives to AWS Lambda, so let's say we configured our AWS Lambda to support Node.js runtime environment. We choose the Node.js runtime environment in this specific layer, and then now the control will, let me just, so now the Lambda will take care of what to be taken into the consideration. Once the request has been received from Lambda function to the Lambda handler, here I was talking about Node.js Lambda handler, right? So Node.js also has to support request receiving the information from Lambda, AWS Lambda, and also it has capability to response back. For this is an unknown area for us, right? You know, Node.js, how the Lambda, AWS Lambda, we can connect from a Node.js application, that I'm going to cover after this diagram explanation. I'm going to went through the deeper flow how it is going to be work internally. So once you have the request received to Node.js Lambda handler, and now, so here is actual our hero, like Express.js is our application where it is gonna use or else expose our JavaScript runtime environment, which we written the JavaScript piece of code that is going to be exposed as a server service API endpoint. Previously, for any web application, right, you want to use Node.js as your backend, that time you're gonna create an Express server and you're gonna define your routes over there. So when we say routes, that's going to be exposed from HTTP and then HTTPS, or else you can use the WebSocket also, whatever the logic that you want to trigger. So this Express.js will have its router and router will take care of routing. Based on whatever the route endpoint it is received to the request side, it's going to route to that respective controller, and from there the corresponding logic is going to be executed, and there is a final response is going to be sent back. Similar way here, Node.js Lambda handler will send the wraps Express application the request, and Express.js application should has to own the responsibility of sending back the response. Now Express.js has been sending the information, as I said, right, the same information. Routing middleware, it has to take care of the routing information, and there the microservice, the whatever the logic, every microservice, as we discussed it yesterday previous video, we've been discussed about the complete life cycle of one use case in an e-commerce application. One microservice will have an invocation with another microservice. It can also have to talk with a database, or else it can also have an interaction with the notification message, or else it can also have another interaction with another broker message kind of thing, or else it will have an message queue kind of thing, where it is going to host a message. From there the message will be broadcasted as a notification. Depends on the situation. Every microservice has its own specific business logic, and this microservice is going to be execute the logic, as I said, right. It may interact with the data store, it may gonna perform some email notification task, whatever it might be, the final response will be sent back. So this is what the flow that we discussed in our prior video. Now let me just go. So as continuation to that, I'm going to discuss about the flow in a better way. So the Node.js microservice AWS Lambda using serverless HTTP wrapper, as I said. So the first web app request will come to the Amazon API gateway. From there, the AWS Lambda triggers a function from AWS API gateway. It is going to accept the HTTP request, and it should also have a capability to send back an HTTP response. Now, so from AWS Lambda, as I said, right, you'll have an Node.js services. So let's say I have two applications here. One is Express.js app 1 and then Express.js app 2, which is going to be set this AWS Lambda, which has been set with Node.js runtime environment. So it is going to capable of running the Express.js code what we written here in the both the applications. Now for that, to have this integration, we should have one serverless HTTP, which is going to do the connection between from your Express.js app to your AWS Lambda. So from AWS Lambda to an Express app, which is executing in Node.js, it's going to connect both of them with a library, npm library called serverless HTTP. So this serverless HTTP will connect your Express related whatever the controllers or else the service endpoints, CRUD operations that you written. So those will be connected to AWS Lambda as a pure JavaScript functions. So whenever an HTTP request comes in and then a router is identified from the controller, so this serverless HTTP will take care of that life cycle. So AWS Lambda first point of contact would be on the Node.js application, Express.js application is serverless HTTP. It will take the call. From there, it is going to delegate the responsibility to the Express app, and Express app it's have its own routing informations, right, based on the routing which controller it has to route the request back, and based on that the respective controller will have an execution with the database and get the response, and then we'll update the response back to the Express application, and from Express application it's going to send that information back to npm serverless http. From there, the response will be received to AWS Lambda as a plain function response, what is the outcome. So from here it is going to be sent submit that response back to the API gateway, and API gateway finally responds back to your application. So that's how you're going to achieve a serverless architecture with Node.js microservice with the help of this serverless HTTP npm package, exporting that into our Express.js applications. Here we covered a use case with two Express.js applications, which is of two different things. And let's say one AWS Lambda should not have only connect with only one Express.js application. It can also have connected with multiple services. Here I was discussing about it was being connected with two services. One service it's gonna be held in by Express.js app 1, and the other service is gonna be held and then maintained by service 2. So both are two different Node.js applications, let's say, that are been running with Express.js and is that are having a package called serverless-http, and serverless-http will have an interaction with AWS Lambda, because AWS Lambda is gonna only execute the plain functions. So those plain functions it's gonna be executing, and this serverless-http convert your web server endpoints that you written on API side, right? Those will be converted into plain function, and that function will be triggered automatically. This is how the life cycle is gonna be happen. And we covered here with DynamoDB one controller express app. Similarly, another controller express app is connecting with Oracle ODS in this example. I hope you enjoyed it. Thank you. Please do share, comment, and subscribe. Thank you so much.